Today we're going to be talking about modules. I know everybody's excited about modules. Who here has more than one module in their app? Put a hand up. There we go. This is already going to be an easy crowd, I can see. Very good to hear. Well, I don't want to take up too much time with intro work. It seems like we have people sitting on the ground right now. There are some seats up front, but I apologize if you're up front. You have a seat next to you with a backpack that you've now just lost. But anyways, let's kind of get into it. Today's talk, we're going to be discussing modules and module mayhem, and I'll share some tales from shared business logic. Just going to give you a brief outline of what the presentation will actually look like. Just like any other sort of basic modularized approach, we're going to talk about why someone would go with a multi-module project. Then we're going to talk a little bit about the Peloton story, how we got into it. And then my favorite part, the actual aftermath of it, we've had a multi-module structure in place for quite some time. And definitely, there's growing pains that we're going to talk about going into that. But I think there's also some pains when you're at the end of it, and certainly taking advantage of an already modularized code base is something that is a bit tricky to do. So we'll talk about, some collaboration conundrums, some developmental dipsy doodles. This is a very alliteration-focused presentation. If you're not into that, I apologize. But then we'll go over some key takeaways at the very end. Before we get into all of that hullabaloo, I'll tell you a little bit about myself. That's my personal website there. It's in the theme of Windows XP, peluso.dev. But my name is Dan Peluso. I'm currently working for Peloton, a very large company, a lot of Android developers as well. Previously, I was at Whoop. They are a Boston health tech wearable, also a pretty large app. And then before that, I was at Python. Python was a startup that had a product pretty in between, a commercial aspect at the time that I was there. I don't know if folks have worked for a startup where you're kind of moving from grant to grant, building a demo for one presentation and then kind of trying to get some capital moving around product to product. That was kind of my role there. I love that opportunity. It was kind of what taught me Android development, and it was definitely my first experience of a very messy startup-style code base and all the craziness around that. I think that every Android developer has a little spot in their heart for activities that contain all of your app logic. But fortunately, we've moved on to that and are into some more legitimate organizations. Additionally, I'm a Google Developer Group Boston Android organizer. GDG is a pretty cool organization. Basically, if you're not tired about code from your 9 to 5, you can go to Jaho Coffee House and complain about Kotlin and Compose or Gradle with a social group. We also help put on some conferences in the Boston area as well. In addition to that, I'm a local musician. I play drums for a group called Spiderwater. I have a hoodie, but it's way too warm for me to be wearing that. I'm actually wearing it in the picture above with my fat ski pants. I'm also an amateur triathlete. droidcon is definitely the primary reason why I'm in town, but on Sunday, I'm actually going to be joining a group of people who are swimming from Alcatraz to the bay and then doing some biking and swimming after that. I'm very scared, so if any anxiety is coming through in this presentation, I promise you it's more about drowning and potentially getting eaten by a shark than it is about modules. I think all things considered, modules are pretty chill to work with. But yeah, I'll be in town if anyone wants to watch us swim. All right, let's actually talk about code for a second. Specifically the why of multi-module. Now, this is a topic that we've discussed at this conference. Certainly online, multi-module is being discussed pretty frequently. So I'm not going to spend too much time talking about this. As you can see, even if you filter it by Stack Overflow, there's literally over 350,000 results and answers about why you should go to multi-module. So I'm going to try to adapt it a little bit into why Peloton went into multi-module so that we're avoiding just some of the high-level descriptions. This is the Peloton case, if you will. And particularly, we're going to be talking about, kind of earlier stage Peloton. If you're familiar with our suite of products, we kind of have a lot of different sorts of front-end experiences. But this is kind of starting with our initial bike. We sort of in 2014 launched, and from 2014 to 2018, there was kind of a multi-module refactoring that sort of began and got to the messy level that it was. So this is kind of the timeline that we'll be discussing here. The number one reason you should go to multi-module, no surprise. Does anyone want to guess it, actually? I bet you could figure out what the next two words are going to be on the slide. Build times, absolutely. I almost am considering getting a tattoo of this Gradle build running thing from how much time I've spent looking at this in just pure sorrow. Now, it is definitely the silent developer productivity killer, and there's kind of two sides to this approach. Now, on the local side of things, I think that that's definitely the most direct pain point. Certainly, if you have many developers in a single module, updating local branches is just a nightmare. And the more developers you have sort of go on board, every time you pull and someone is adding to this just massive module, your dependency graph is so complex that it's going to take an incredible amount of time. Given the time context as well, the compiler back in 2018, was not as smart as it is in the 2024 compiler. So, I think that yes, there are efficiencies that you can take, but certainly back then there was less so. And that kind of added to our issues. In addition to pulling from the main branch, we also had adding a new dependency, leading to incredibly long build times. Let's say you wanted to add some sort of library to deal with a particular image loading efficiency, or maybe even something like an analytics platform. Something like that would be a 30-plus minute build sometimes, just given how messy those initial modules were early on. At the time, it would have been nice to kind of take the bottom panel approach here and just buy everyone M1s. And I'm not going to pretend like I don't have an M1 in front of me and I've taken some, egregious steps sometimes that this can a bit cover for. But certainly that was not the case back then. And especially when you want to build something to scale, it's something that you want to avoid. Really, the local issue is one thing, but there's also the concept of remote builds as well. Pull requests in general are probably the most intensive piece of this. Definitely, it's more difficult to parallelize those tasks, especially if you have different flavors and varieties of your product that you're running. Maybe linters that are running on certain modules but not other ones. Parallelizing that is something that you can only really do when you take that multi-module approach. And then the merge queue was also slow. I'm sure y'all are no strangers to a Friday evening merge queue. Everyone trying to put stuff in before the weekend. Maybe you follow a release cycle. That's like a 5 p.m. cutoff, in which case I do apologize. That seems like a horrific thing to deal with. In our case here, we would sometimes see hours-long merge queues just to run all these tests and make sure that something doesn't break in the master branch. And even still, sometimes it would break the branch. These things wouldn't propagate as soon because you would have a slow merge queue. And by the time everyone is basically at the bar, only then do you figure out that the second of like a 10 list of merge queue commits is going to actually break something. Now, I wasn't a Peloton employee in 2017. I was actually in high school, but I have to imagine that this is probably what it looked like at Peloton. I don't really know. Something about the the remote server type. Now, the number 2 reason to go to a multi-module approach: sharing resources. Who is a lazy developer in the room? There we go. Sometimes you don't want to write something when something has already been written. Why use lot code when few do trick? Certainly in the case of a styled modern app, you're submitting things that are pretty often hierarchical or at least borrow styles from your existing projects. Repeating that styling across was pretty normal, and so you really shouldn't have to worry about redoing all of your views. This is also predating Compose, so even while it was more hierarchical back then, we still had the issue of redrawn components, and particularly with designers, having small implementations that would mean having to rewrite a new Java view. Things like utility methods were just all the time being tossed around and repeated. I couldn't tell you how many ways there were to format a date from our server into a string. That's a problem that really should only have to be defined once for your product, or maybe in one class, but we just had it all over the place. And from a developer standpoint, onboarding was really difficult, I think, in this time. You could look up, okay, maybe I'm building a view model for this feature. What are the other view models looking like? And you would just have massive examples across directories of what different approaches look like over the years. Certainly it's nice to look at the Git log and go through that, but a lot of the times that isn't going to be as descriptive as what you're looking for. There's not really a higher level directory structure for what you need. So as a new engineer, hell yeah, it could be hard to decide what you want to use. You really have to pick like your favorite developer, or look at the most recent commits, or even just following the style of a team. It's not really something that's scalable in that sense. I'm going to grab a drink of water before we surprise y'all with number 3. All right, the number 3 reason, supporting multiple platforms within the same code base. Who here is using Kotlin multi-platform? Okay, that's awesome. I love Kotlin multi-platform, but I am in no way going to be able to convince the higher-ups at my company to move into Kotlin multi-platform. However, we as a company decided Android was our favorite operating system. We've had specific flavors we liked. I think the JVM engineers were stronger than the iOS engineers, so we were able to physically overpower them and declare that this operating system was the best. And certainly we decided that Android was going to be the best for our product. Now, this is the bike that we're looking at. We've gone a little bit more in the timeline, so maybe it's got a newer, sleek feel to it. There's some cute fitness classes going on. You can turn the screen there. This is our flagship product, no doubt. We also have the treadmill, which you'll once again see has a very similar tablet at the top there. Pretty similar user experience as well. I'm no product guy, but I think alignment in those experiences is overall a good thing that we wanted to keep. So these are more or less running the same version of the app. Fast forward a little bit more, we wanted to support a rower. This is another device which is going to be basically using the same connected fitness experience with that screen on top of it. So supporting that was something that's important to us. Now, early on in Peloton's phase, we knew that there was a mobile app component that you wanted to add to the fitness experience. And so the way that they did that back when the company was a little baby company was with React Native. Fortunately, someone came along and eventually said this and decided that a native approach is probably better. And I think that phasing out React Native and then introducing it into the same code base really was the first big step that we had to having a true monorepo with different products that we were compiling to. This is what the digital app looks like. Again, repeated styles, same endpoints, authentication. There's a lot that could be extracted and put into common modules here. I'm still not done yet. We have our Watch OS app as well as widgets. Our Peloton Guide is yet another product that is running Android. This is a HDMI sort of, do fitness classes in the background sort of a deal. This, again, similar styles, a similar product. We really thought that it would be best for us to combine all of this logic into a shared monorepo. So that's the approach that we have. Lots of different products, lots of different things going in, but using same sorts of business logic. At the time, a lot of these products, granted, came around while we were already into modularization, but certainly early stage, it was really tough to support these different versions and kind of different flavors of our product. We had all these targeted devices here, and even in addition to them, we had different experiences for them. Let's say you have the version of your connected fitness hardware that lives in your home gym. That's certainly going to be different than the one that you guys are using in the Hyatt Hotel or whatever partnership, office Peloton that they have there, as well as if you go to the studio and you have a chance to take a class live. Once again, a different version of the app. Definitely not different enough to justify a new repo, but taking advantage of that monorepo can really allow you to reuse a lot of that logic. So we totally committed to JVM. This is what we were going to do moving forward. How can this kind of apply to your product? I do understand that Peloton's in a little bit of a unique experience in that side of things, and so I do want to make this a conversation that we can apply, and maybe you guys can learn some lessons or at least provoke some thoughts about how you can use this. Maybe you want to have an app for a restaurant where there's a server and a client version of it. These are things that could be built from the same monorepo, have shared modules, but still have apps that are sort of taking advantage of that common business logic and UI. Maybe you have an enterprise version of the app for doing large-scale studies versus a consumer app, which is more of a traditional subscription-based model. Maybe you're just targeting different devices. I have an uncle who is pretty diehard Android Lollipop fan, and he's constantly getting frustrated that people aren't supporting him. I don't know why, but you know how some tech people are around not wanting to upgrade things. I respect his hustle. If I build an Android app, I'm probably going to have a certain module just using lower-level APIs. Maybe you're trying to build something that can fit the whole worldwide Android community. If you want to target these different things, having a different module within a monorepo could help you sort of save those efficiencies as well. Really, KMP is great, but Android by itself can be pretty cross-platform without needing to add those dependencies. So we started off with our 2 modules at Peloton. How the heck did we go from 2 to 2,000 modules? Did you like that little transition? That's a little alarm action there. Let's talk a little bit about how we got there. So the first most jarring question that you're going to have to go through is, with what time are you going to be able to refactor this? Remodularization, I'm just going to keep it a buck. It's not a very pretty process. There's a lot of build times, a lot of developer efficiency, and straight up, sometimes it won't even be faster for a good chunk of time until you've removed that business logic. So you're really going to have to come up with a plan to convince the C-suite of your company, or even just higher up vice presidents, why should we be taking on this massive initiative? And this is really where you have to do some number crunching. I'm no accountant, but calculating build times and cost is something that you do want to put in front of business as just sort of an incentive to argue. Now, build times is something that you can already pretty easily access with most enterprise plans. I've made together a little equation for you if you're not feeling too confident on it. Let's take the average hourly engineer salary times the number of pull requests times the average number of builds per pull request. I'm talking to all you people with your, spelling mistake commits and maybe like one-liner commits. Build time in hours is another factor into that. I think having that number is good and being able to, show the equation is nice, but I think what really gets business going is when you actually illustrate that exponential curve to them. As you can see, I developed this one in Microsoft Excel and, adapted it to this n to the fourth equation here. You can see this is what our graph looked like. Look how many more coins are on the right side. This is a major concern for business people. I don't know what they talk like, but I have to imagine that this graph is going to sell them immediately. Okay, so you've got the buy-in now. Where do you start with this massive overhaul here? There we go. For us, it was utility functions and DTOs. As simple as you can get. It's kind of like giving yourself a little treat reward in a very long battle that you're going to have to fight with modularization. Think about a DTO. You really only have to get the Java serialization library, and everything can depend on that. And you have, already your first step of modularization. Something like utility functions I mentioned before. There's a lot of space for improvement around unifying those and building good classes there. These things don't necessarily have a ton of dependencies. They're used ubiquitously across the app, and it is very simple to test this sort of logic as a whole. The next step, I think, is starting to build new features as modules. Now, this one is definitely a lot trickier than the previous one, so you are going into a little bit of a battle with this one. But I do think that if you are going to start adding new tech to a stack, as you're probably all aware, you have to start building what's new in that style and being able to integrate that. I think particularly with multi-modules, it's not as difficult to mesh with other parts of the code base. So it is a bit easier than, let's say, adding Compose to a code base. But it can still be difficult if you depend on the Android SDK or other features. Let's say you're in the case of the startup company where everything is living inside of your main activity. Sometimes creating new features as modules isn't going to be helpful if you have so much poorly written logic from the start. And I say poorly written logic not out of contempt, but mostly out of, a timeline, right? An early company doesn't really have time to make everything perfect early on. Unfortunately, that is going to make this step a lot harder, but it's something that all companies that experience a hypergrowth are going to have to experience. Peloton is certainly no, stranger to the hypergrowth phase, and I think that particularly taking that early code from engineers that maybe wasn't as scalable and then adapting it to this was a pretty difficult task. Now, determining which components make the most sense to share is also a pretty important step here. Now, it's great to build everything in a generic sense. You want to build everything to be as adaptable as possible, and that is something that takes time, admittedly, and sometimes it's not exactly worth it. You have to decide if the feature you're building is something that is going to be expanded upon. Maybe if it's seen as a smaller company initiative or sort of a patch of something, that might not be as good a candidate versus a new adaptable settings page that you sort of want to remodularize. So consider that, yes, it is good to make things generic and extract them as modules, but also understand that by doing this, you're developing that piece for scale. So you need to keep that in mind and see whether or not the update is actually worth it. All right, this is my AI-generated growing pains image here. As I mentioned, it's not a very easy process going to modularization. Particularly, modules would be small, but depend on a few large ones in our case. We were trying to extract that logic, and build time improvements were just completely negligible. It was much harder at first to go into that. It was also difficult to figure out a structure that worked for our team. At first, we thought, okay, the top-level modules for our project could be new features. So let's say, for example, if I wanted to extract settings, I could have a settings module. Submodules within that could be for our different platforms. Let's say bike settings, digital app settings, watch settings. For us, we thought that that was going to be an immediate piece. Pretty much immediately we learned our lesson that it wasn't going to work super well. And we ended up going by platforms rather than features on the topmost level. I think this makes a lot of sense, especially if you're adding build processes based off certain modules. It makes it much easier to make independent pieces and parallel builds while you're doing that from a top level. For tooling as well, right? Running, a /gradlew command on a top level directory and making sure that everything that's inside of that product is going to be updated is also a pretty important factor. So I would consider doing it on a platform by platform basis, with a shared module being sort of a top level piece for catch all any shared logic going inside. All right. So we did the why, we did the how. Let's kind of bring it back to where we started. Again, a very simple timeline develops here in Draw.io. Peloton gets released. We started our multi-modularization. I would say around 2020 that starts to stabilize, and I didn't start until 2022. So I'm going to share a little bit of my experience as the young developer going into this multi-module. I've shared the history of our ancestors in the code base, but what's it like to actually work with this? What's a tale from shared business logic I could bring to the table? This is a picture of me with Jess Sims. Have you ever taken a Peloton class? She's from Boston. She's pretty cool. She likes to challenge people in her classes to Mario Kart. She talks a lot of game, but there's basically no shot she could beat me. I think she's using a bike. Like, come on. Anywho, let's talk about collaborating within our code base. So the example that we're going to follow here, and I'm really hoping this video plays, is a feature that we recently released in March around privacy settings. What we're looking at is sort of the home tablet experience, and that's the team that I work on. We're going to see what it looks like to switch a user and immediately hit them with a prompt on login. Every user's favorite experience, right? To have a experience blocking dialogue thrown at them. In this particular instance, we were looking at the locale of a user. Now you'll notice we have, this is actually all built in Compose here. We have our responses, certain cities. If you look, I'm looking for Washington here. If you're familiar with privacy laws, Washington is definitely a very particular state around how they want to handle that. The requirement for the product was that we were not allowed to personalize any of the experience without asking for explicit user permission. So we had a shared feature release. We wanted this to be available for someone who uses the Peloton phone app, the Peloton bike. Even at the gym, they use it and log into that. So it had to be basically in all of our products, a unified experience. I think the other interesting or difficult factor with this was the legal component to things. Has anyone here had a tight legal deadline introduced with product? Raise your hands. So you can probably relate to having, let's call it a degree of freedom into the mix with the legal team members. It's not really the same as having, a excited product manager want to push out a feature on time. So we had a very hard deadline that we had to meet, or else we're breaking the law. So teams kicked off design, and maybe you've also experienced this as well. As front-end developers, a lot of the times we're sort of the last step in the feature development. We're building what a user interacts with, but we're also building it after the design has been built, after the backend has been built, after analytics has been built. If any of those teams have misestimated or are taking more time on that, it goes on us to sort of make up that, and we are basically the last step before release. So we were in that situation exactly. It was basically on us to catch up and do this, release it, and get it through before that legal deadline. So the front-end teams hop on last, and then in my own position, other teams had basically already started this. We had a previous feature that we were developing, take a little bit more time. It was a less comfortable rollout than we would have liked, so we started a little bit late there. I was in a position where I knew that I was not going to have enough time, given some of the constraints, to release this. So what we decided to do was sort of extract that logic and try to make as much of this feature shared as possible. Now, in my case, some teams had already started development with these designs. So the first step, which is nobody's favorite, is sort of taking the collective responsibility of extracting features that another team has already built into shared modules. Basically, immediately I knew that the way that different teams have siloed themselves and different styles was going to be a bit of an issue with how we wanted to collaborate with them. How many of you have experienced a time where maybe there's teams working on different features? It could be something like 2 Android teams or 2 iOS teams, and that team has a completely different way of coding than your team does. Has anyone ever experienced anything like that? There's a lot of style discrepancy, and there's a lot of sort of social politics around MVVM and MVI. Maybe this is somewhat of your situation as well. I don't think that it got this intense at our company, but certainly you can catch the idea. Certain teams prefer different patterns, and when you want to extract that, certainly across platforms and sort of defy the norm, you are suggesting something that is going to be a bit trickier. So you have to decide on what level you want to share logic. Maybe you want to do only the repository. Sure, that makes sense. Endpoint calls are something that you definitely don't want to have to redefine and repeat. Maybe something like a cache implementation is going to be a bit trickier. Maybe the platforms are going to have a little bit more control over the view models. Maybe you're working with a tight deadline and you only have a couple months to release this. Maybe you can do something like sharing a view model. Now, this is something that I definitely wouldn't immediately recommend. Obviously, you're tying a little bit of the platform experience to a shared piece, and I think that it can be difficult to extract that. But in our case, we wanted to get as much as possible there. Something like observable implementations, maybe the diehard RX head doesn't want to leave that go and you have to sort of adapt to that. That's a lot trickier when you're sharing a view model and you're a coroutine queen. You can't move into that as easily. Maybe there's API limitations on each platform as well. Our product that I was working on is the tablet itself. We're kind of siloed in on our own API level. We can push out devices, whereas the hardened sort of phone app engineers are really targeting everyone. They don't really have as much control over that API. So that's something to consider as well if you're going for that approach. Overall, you need to balance the shared logic with platform requirements for each one. Other things that you want to consider along this, does this need to support future clients? Maybe there's another device that you're developing that's going to have to implement this feature. How do we make it so that it works with that pattern? Are there differing experiences? Maybe the UI is different enough to where it doesn't make sense for you to share how that's being displayed. How important is the release itself? Maybe there's a little bit more wiggle room for platform engineers to kind of adapt their particular architecture on something, or maybe there's a legal deadline and you haven't slept in 2 weeks because that the company's at a very tough position if you guys don't put this together in time. In our case, we had a risky release that we wanted to deal with here, so we wanted to share a little bit more than typical logic for this position. So, this is probably the most standard practice for sharing business logic. We decided to go with this one, and we actually had a much more in-depth view model for these differing platforms. Now, as I've kind of alluded to before, this is certainly an untraditional approach here, but a lot of the times you have to analyze the business implications to justify these sorts of decisions. As I was saying before, when you're in a startup, you don't have a lot of time to get the architecture right and build things in a nice way. You sort of have to move quickly and make a lot of mistakes. In our case here, we had a QA team that was working with a shortened timeline. If they want to take Lunar New Year off, we're not going to have them, take away a holiday for our Taiwan team to avoid doing this. It's on us to develop things earlier and work with them to make sure that release can go forward. The experiences at first weren't exactly aligned, but as engineers, when you bring up this problem earlier on, you can sometimes get buy-in from design and product to really kind of move it to a more unified experience and say, hey, it would be a lot easier if this was a one-to-one match on the bike and the phone. Is that something that we have the ability to do? Again, legal deadlines aren't exactly malleable. I don't think that any of the lawyers were too happy hearing that this project was going to potentially be delayed there. So, you have to play nice with them. Dry principles as well could also save us if there was a bug. In the case that we did have the shortened QA and the shortened release deadline, we wanted to make it so that a fix could happen across all platforms all at once. And so having that single source of truth was really important to us as well. And we did it. We avoided violating privacy laws. Maybe not the most glamorous stub. Certainly the picture is probably a little bit happier than the remote celebration was. I think there was like a couple like Zoom confettis, and that was basically it. But let's talk a little bit about maintaining it. You've released it, you got the whole thing out, but now you have to maintain it, and you've basically made it too many cooks in the kitchen for one sort of feature module. How is that delegated across those teams? These are questions that will come up when you're doing this. Which platform is responsible when a bug comes up? If everyone sort of worked on one piece of the pie, is it ownership based off of which feature you worked, or is it a collective based off of platform to platform? What happens if a bug only exists on a single platform? Or, in different teams, right? Aside from engineering, are analytics also going to be shared on this shared feature that you're making? Maybe DevOps monitors. Is that something that you've built into the shared logic, or is that something that different platforms are handling easily? It's nice to kind of share everything, but these kind of secondary effects of that are things that you need to keep in mind when you're developing a sensitive feature. Shared logic definitely has to mean shared maintenance. Maybe it looks something like this, a very happy collaboration between two Android engineers. These are, pretty standard looking Android engineers. Maybe it looks something like this, where there's a lot of blame getting tossed around, and this is kind of the anime model. I really just like how humanoid they've made them in this one. Blame getting tossed around is not the best thing, but certainly, especially when there's sensitive deadlines and the team is collaborated together, it can sort of be some inter-team conflict there. So play to your team's strengths. In my case, our team was pretty UI heavy, and we had a lot of Compose developers on our team. So we decided we're going to own everything that could go wrong with Compose. If anything came up with a Teams issue or there was a new request around a feature, we wanted to pretty directly go to that. Backend interaction might be another team's specialty. Maybe unit and integration tests, if a team went on later, they could handle covering those and building out that testing suite. Consider availability as well. As I mentioned, our team wasn't able to start until after other teams. Maybe it doesn't make the most sense for us to define those crucial business class interactions earlier on, and maybe teams who start first should sort of build that. It's nice to think that a team that's building a shared feature can do it in parallel, but I think we can all agree that that experience isn't really as easy as said. There's a lot of steps that happen in order that you need to consider around teams' deadlines. Now we're going to talk a little bit about some pros and cons about being within the shared module code space. Pro, faster build times. I think we've hashed out this one enough. Obviously, it's something that is tough at first, but definitely pays off and is crucial later on. What does that mean on the negative side of things? Well, in our case, as a developer, you're going to have to do much more frequent Gradle syncing. In my personal experience, it could be pretty annoying to build a new module and have that first day basically be you forgetting you've imported some sort of time or authentication or some crucial module, and then having to resync it every single time you want to use that. Maybe you feel comfortable developing in a Wild West, all of your dependencies are read, you do it at once setup. But certainly the auto import doesn't work that well for all companies. It does take a lot more time to sort of find out which dependencies you need for your shared feature, and that is something to consider. Now, does that mean you shouldn't do it? Probably not, right? I mean, it is more overhead, but at the end of the day, it kind of takes some of the build responsibility and puts it on the developer rather than on Gradle, giving Gradle a little bit of a break there. Another pro, less rewritten logic. Oh my goodness, I need a little water after that. Good grief. I don't think anyone's going to argue against dry principles, so we probably don't have to spend a lot of time on this one. From an organizational standpoint, from a developer relations standpoint, it's just much easier to have things unified and to have a single source of truth for that. So definitely something important as well. The added process around adding a new module is certainly something that you need to consider with this as well. Think about, in the specific case of you're building a new feature, that amount of time it takes to make all the dependencies. As I mentioned before, what is this going to depend on? How can this fit in? Maybe you're not as comfortable adding a module in and then getting approval there. Maybe you have to do the README and sort of define what that module is doing so that later on people can understand how to use that. It is something that adds a bit more process to making a new feature. That can sometimes be something that's difficult to work with. Now, I do think that there's a lot of opportunities for improvement in the modularization space, and certainly I think Gradle scripts can be kind of a fun way to motivate developers to do this within your organization. A very easy one, or not easy to make, a very nice one to use as a developer is having a module creation script. Basically taking what I said before about the time it takes to initialize a module and add it to the code base, and maybe having a couple commands to do there so that an engineer basically only has to decide generally what they want to pull from and add the README to that module. If you want, you could try to use the Module Android Studio tool. I'm going to be honest, I learned about this one yesterday, and I think that it's a pretty cool feature. Couple issues to track along with that, but certainly it seems like modularization is being supported from a tooling standpoint, and that's something that you can take advantage of as well. The other thing is optimizing build pipelines for those specific modules. So if you do share a monorepo, maybe things like having pull requests only perform checks on the modules that you impacted, maybe being able to build a dependency graph and have visualizations around that within your CI process. This is something that can save a lot of time and is really a good way of fully taking advantage of this modularized approach your repo is now in. All right, let's go over some of the main takeaways and get on with the rest of the conference here. Modularizing our code base was well worth it. I'm actually going to take this one a step further. If you have a large enough company, this really is not an option for you. It really is necessary if you want to support lots of developers, lots of code, and differing products there. If you haven't started it already, justifying that and building up your sort of reasoning for doing that is something that is incredibly important to your process. Any shared feature release should be adapted to take advantage of shared modules. So, now that you've built this, you have to have the buy-in. Make sure that if you're building new features, you are adapting it to fit this. And particularly if you're deciding the architecture for something, try to find out what shared features you can already use and how you can make yours as adaptable as possible to whichever platform is using. The earlier you decide to modularize, the easier it will be. I think that this is probably, a little bit of a tough slide to look at if you have experienced the modularization and seen that refactor process. Obviously, it's a lot easier if you decide earlier on to do it. So if any of you have a cool startup idea and you're working code, trying to get the quick and dirty adaptation working, just know that if you do ever take off and have more engineers joining, that this is something that will save you a lot of time if you're thinking in this manner very early on in the stage of an app. If you're late stage and you're trying to refactor into modules, I do apologize. It's going to be a tough pill to swallow. Anyways, this is kind of the motto that we have at Peloton. Together we go far. It's all about collaboration within the team. And so as long as you and your platform engineers across different teams are Android developers, you share that common bond. We're all part of the same community. And no matter what you're supporting, you are hopefully writing Kotlin and Java, and you're supporting this environment. Be sure to collaborate, and I'm sure you're going to have an easy time working with other Android devs. I think we all sort of speak the same language around this sort of thing. And yeah, it's all about collaboration in the end. Thank you guys so much for joining the talk. I think I'm like 20 seconds there. If you'd like to chit-chat with me, my LinkedIn is here, my personal website as well. You can also ask questions at the end. I don't know if we have time, but come see me after or any time in the conference. And enjoy the rest of your weekend.